here is an indefinite integral where it doesn't appear that I can use substitution or by parts. You're going to need to start thinking about all of the integration strategies that you know, and we need to start working on the process of selecting the most appropriate strategy. My general advice to students is you should start by thinking about the easiest strategies that you know, like substitution, right? That's much easier than trig sub. So you take a look at a problem and say, will substitution work? No? All right, maybe I have to use by parts, and that won't work either. Okay, well, I guess I got to use trig sub. It's a little irritating, but we can do it. So this is going to happen in several steps. The first thing I'm going to do is make that bottom expression, that's 16x minus x squared. I need to make it look like a squared plus or minus b squared, or something squared plus or minus something else squared. And this is completing the square. So I have 16x minus x squared. So I've got that 16, okay? I take that 16, I divide it by 2, and I square it. This is how I learned to complete the square. You have 16 over 2 is 8, and you square that, and it's 64. So I am going to add and subtract 64, right? It's not like I'm changing anything. 64 minus 64 plus 16x minus x squared. Great. And then I have my first 64 over on the left there. And over here, can you see how I factored out that negative, and I have negative x squared minus 16x plus 64. If I were to distribute that, I would get all three of these terms over here. Well, fantastic, because that actually is going to collapse to 8 squared minus the expression x minus 8 squared. That is awesome. So now it's time to do the trig sub. So here is my original integral, that this expression is literally the same as this expression. So this is my original integral right here. So now I refer to my little cheat sheet of trig subs, and I see that if I see an expression that looks like a radical thing squared minus other thing squared, that is a substitution that I'm supposed to do, x equals a sine theta. The only thing that complicates this a little bit is that that's not exactly the expression that I got, right? I have thing squared minus x minus 8 squared. That whole expression, x minus 8, is what's squared. And so what I'm actually going to do is set x minus 8, that entire expression, not just x minus 8, I'm going to set that equal to 8 sine theta. Okay, and if I take the derivative, then that's going to make dx equal to 8 cos theta d theta. Now, making that substitution, okay, the x minus 8 will transform into 8 sine theta. See how I took what was in the parentheses before and I just deleted it and replaced it right here? So that turns into 8 sine theta. This dx is going to disappear and be replaced by all of that junk, 8 cos theta d theta. Great, the substitution is now complete. So now it's time to simplify and integrate. So I have that whole mess from the previous slide, and a couple things are going to happen here. One, this 8 is going to cancel out with these two 8s right here. You can try this yourself. Out of this radical, you will be able to factor out a 64. The square root of 64 is 8, and that will cancel with this other 8. So what I'm going to get is a cos theta on top, and on bottom there's going to be a radical 1 minus sine squared theta left, and then there's going to be a d theta. The second thing I'm going to do is I'm going to use this identity, 1 minus sine squared equals cos squared. And so on the bottom, it's going to say radical cos squared theta. Now remember that if you square something and then square root it, it doesn't just cancel, you actually get absolute value, right? I mean, think about what happens if you were to take -4 and you squared it and then you square rooted it. You would actually get +4. So squares and square roots do not cancel. Don't think that they do. You actually get absolute value. It's just a happy thing in this problem that cos theta is going to be positive all the time. The reason is because of the technical way that trig sub works is that you have this restriction on what theta can be. Theta has to be between -pi/2 and pi/2 in order for the substitution to work. And between those two values, cos theta is always positive. So that totally gets me out of a tight spot here. I don't need to do a complicated integral. It's actually just going to be the antiderivative of 1 with respect to theta. And so it's just going to be theta plus c. So I was really happy to squeak by on that one. But I'm not done. It would be great if I could just respond with theta plus c, but I need an antiderivative in terms of x. And so I need to convert this expression back to being in terms of x. So I have theta plus c equals. What is theta? So remember that we set x minus 8 is equal to 8 sine theta. Unlike a lot of the problems on your homework assignment, I don't actually have to draw any triangles or do any craziness right now. I'm actually just literally going to solve for theta by dividing by 8 and applying the arcsine function to both sides. So I get that theta is equal to arcsine of the quantity x minus 8 divided by 8 plus c. And this problem is completely completed.